Okay, so lecture 28. This is going to be the practice review test. If you don't know, we're going to have one assignment this week since we're only in school for 2 days this week. It's going to be a 10-question test, and this is just going to be practice for it. So I'm going to be looking at the practice review test that I put onto Canvas, and we're going to be working out some or all of the problems. Okay, let's look at number one. So number one says, I have an absolute value equation x minus 6 equals 12. Okay, so for any absolute value equation, what you want to do is you want to make sure that you take whatever out of the absolute value sign you can, the way it is. So I'm going to take this thing out, and it's going to be x minus 6. And what I can do over here is I can make sure that this part is plus or minus. I want to make sure that part is plus or minus. So when I do these two equations, I'm going to have the right side being a positive number, and then I'm going to have the right side being a negative number. So let's look at that. So we have equals positive 12, and we can also do x minus 6 is equal to negative 12. So the only thing that's changed is the number on the right side. You know, you could have a positive 12 or you could have a negative 12. And then I just solved both for x. Okay, so what I'm going to do is I'm going to add 6 to both sides. And I get x equals 18. That'll be my first answer. And then over here, I can add 6 to both sides. And when I do that, I get x equals negative 6. So these are going to be my two answers, 18 and negative 6. And I'm going to put them both inside a solution set. So I'm going to have 18 and negative 6. And then I close up the set. And there you go. That's the solution set. Now, what I also wanted to do was I also wanted to check both my answers. So we're going to check them next. So let me put a check mark on this side, and let me put a check mark on this side. Okay, so what I'm going to do is I'm going to take my original equation, and I'm just going to plug in 18 for x. So I get the absolute value of 18 minus 6 is equal to 12. It should be, right, if we chose the right number for x. So what's on the inside right here? 18 minus 6. That's going to be positive 12, right? So you're actually taking the absolute value of a positive number. And if you take the absolute value of a positive number, it stays positive, right? So I'm going to get 12 is equal to 12. True. So that means the 18 is going to work. That's going to be one of my answers. Okay, looking over on this side, I'm doing the same thing, but I'm just letting x be negative 6, right? So all I'm going to do is I'm going to plug in that negative 6 in for x and see what I get. So I got negative 6 minus 6, all in absolute value, and it is equal to 12, or at least it should be, right? That's what the equation says. So I'm going to do what's on the inside first. I've got the absolute value of negative 12 is equal to 12, right? So then the absolute value of negative 12 is going to be a positive 12. So that's going to be 12 equals 12. And there we go. So that means negative 6 must be inside the solution set. So this is an absolute value equation. And all you're doing is you're taking the right side of the equation, this 12 right here, and you're making sure that you make that positive and a negative number. Okay? So that is number 1. Okay. Now I need to figure out how to make a new page. I'm not really sure. Let me see. Yeah, I'm actually not sure. So we'll see if I can make a new layer. Maybe that's what I need to do. Add a layer? Can I do that? We'll see. Okay, but I'm still on this layer, so maybe I need to check it. Not sure about that. But okay. This is number 1. I'll leave that up there for a few seconds so you guys can get that. And then maybe I can erase the whole thing. Let's see. I'm probably going to have to select something. So let's see. I'm going to move this down here. And I'm going to select. That sounds good. Then I would have to erase. Or I bet I can just hit the delete key. Yeah, I'll try that. Okay. So let me select. See what this does. Okay. Then delete. No, that doesn't do anything. Let's see. What is this? Deselect. And this is invert, remove, remove. Okay, that didn't do anything. I guess I could set up a new file. Okay. All right, so the layers, let me get those. Background, I'm going to make this black. Good. Okay. So I got my ink, got to change the color to white. All right, let's look at number 2. Okay, so number 2 says the absolute value of x plus 3 is what? Less than 7. Okay, so this is an absolute value inequality, obviously. I've got the less than symbol. So I'm going to have 2 answers, and they're going to be separated by the word and. So I'm using the word and because I have a less than symbol. If I had a greater than symbol, I would use the word or. But since this is less than, I got to use the word and. And what I'm going to do is I'm going to take this x plus 3 right here that's on the inside of the absolute value, and I'm going to let that remain the same. And actually, the negative 7 is going to become the plus or minus. So just like last time, we're taking the right side and we're letting it be positive and negative. So I'm going to have x plus 3 come out of the absolute value symbol. Nothing's changed about the x plus 3. And I'm going to keep everything the same. So I'm still going to have a less than symbol right here, and I'm still going to have a positive 7. I'm going to put the negative 7 over for the second solution. So now for the x plus 3, that's going to stay the same. So that's going to remain the exact same. And what I'm going to do is I'm going to put a negative 7 over here, and I'm going to switch the sign from being a less than to a greater than. So all I'm doing is I'm flipping the sign around. So the main two differences is I changed the sign of the inequality from a less than to a greater than, and then the 7 is going to be a negative 7 over here. Okay. So now I just get x by itself. I need to subtract 3 from both sides. I get x is less than 7 minus 3, that's 4. Over here, we are subtracting 3 from both sides as usual. And I get x is greater than negative 10. So these are the two answers I'm going to have. I'm going to bring down my and to separate these two solutions. And next we can draw a number line. So let me change my color to white and see if I can find a straight line. I do not think that this is a straight line. Drawing style? Ooh. Yeah, I could choose a straight line here, right? Okay, good. All right, so here I have my number line, and what I want to do is I want to put the arrows on both ends, like so. And I need to have two numbers be put on my number line. I need a negative 10. Let's just say it's right here. No, that's pretty bad. Let's go back to freeform. Yeah. Let's put negative 10 right here, and let's put 4 over here, which would mean 0 is probably like right here. Okay, so I've got my two numbers where they should be, and what I want to do is, because I have a less than symbol, I'm going to use open dots. I want to use open dots. So I'm going to put an open dot around 4, an open dot around 10, and the inequality sign is going to show me which way to shade. So let's look at the 4 first. I'm going less than 4. So any number less than 4 has to be shaded. So I'm shading to the left. So I'm going to shade this line till I get to negative 10, and then I'm going to stop. Okay. And that's because we're stopping at negative 10 because it says greater than negative 10. So that means any number that's greater than negative 10, going to the right, also has to be shaded. So if we combine both of these solutions, what you'll notice is these two graphs are going to meet in the middle. So any number between negative 10 and positive 4 could possibly be a solution to this inequality. Okay. Alrighty, I will leave that up there for a couple seconds, and then we'll move on to 3 and 4. Now, if I could figure out how to get another page, then I'd really be in business. Let's see. I don't think it's layers. I really don't think it is. Add group, add image, clear. So if I was to add a layer. Oh, you know what? I'd probably have to hit the I. Yep. There we go. That makes sense. Okay. So let's move on to number 3. Okay, number 3. 3 is going to be a quadratic equation. And we know it's going to be quadratic because the highest exponent is going to be 2. So let's take a look at number 3. Number 3, we got x squared plus 8x plus 15 equals 0. Okay, so I need to find the solution set. So I need to know what two numbers for x goes in this solution set right here. What I'm going to be doing is, because I can multiply to 15 and I can add up to 8, I'm going to be finding the two numbers that actually do that. Now, they got to multiply to 15 and add up to 8. So if I was to draw my MA chart, I would put the M as 15. So I'd write the 15 under the M, and then the A is going to be 8. So I'm going to put the 8 under the A. And what I'm trying to do is I'm just trying to find the two numbers that work out for these two. And I know it's going to be 3 and 5. So I'm going to factor this as x plus 3 and x plus 5. And the whole thing is still set equal to 0 because it's an equation. Okay, so now I can separate it into two different solutions. I'm going to have x plus 3 is equal to 0 from the first factor. And I'm also going to have x plus 5 equals 0 from the second factor. Okay, so for the first one, I've got to subtract 3 from both sides. And I get -3. Over here, I need to subtract 5 from both sides, and I get x is equal to 0 minus 5. That's going to be -5. So my two answers are going to be -3 and -5. Okay, so let's say I wanted to check this. What I could do is I could plug both of these numbers back in for x in my original equation. So plugging it back in, I would have -3 squared plus 8 times -3 plus 15 equals 0. And this line is in the way, so let me see if I can erase it. Good. Whoops. There we go. And then over on this side, I can put in the -5, and I get -5 squared plus 8 times -5 plus 15 equals 0. Okay, so on the left side, I'm going to get a +9 minus 24 plus 15 equals 0. So then 9 minus 24, that's actually going to be -15. And then -15 plus a +15 is going to give me that 0 equals 0 that I want. All right, over on this side, I've got -5 squared. That's going to be +25. I've got 8 times -5. That's going to be -40. And then I bring down my plus 15 equals 0. Okay, so 25 plus 15 is going to give me 40. 40 minus 40 is going to give me 0. So I do get 0 is equal to 0. True. So that means this -3 and that -5 are going to be part of the solution set. Okay, so that is number 3. All right, let me add another layer. Add, good. And let's see, I can hit the eyeball on this. Good. Okay, let's look at number 4. Number 4 is x squared minus 9 equals 0. So this is going to be a quadratic equation just like the last one because the highest exponent is 2. And what I can do with this one is, because this is a square and this is a square, I can say that this can be factored by difference of squares. Difference of squares. So to factor this, what I'm going to be doing is I'm going to be taking square roots. So what's the square root of x squared? That's going to be x. What's the square root of 9? That's going to be 3. So now I've got the square roots going. And I can put this inside of a factor, and I would have to have the same parts inside of the next factor. So I'm also going to have x and 3. The main difference between these two factors is I'm actually going to put a minus right here and a plus right here. But it doesn't matter which order you put the plus or the minus, because you're always going to have an x plus 3 and an x minus 3. So the whole thing is still set equal to 0. We factored it, and now I'm ready to set up my two solutions. So I'm going to have x minus 3 equals 0, and x plus 3 equals 0. Okay, so over on the left side, I'm going to add 3. I get x is positive 3. Over here, I can subtract 3. I get x equals negative 3. So that's going to be my solution set, 3 and negative 3. Okay, let's go ahead and check these two. So if I wanted to check them, I would write out my original equation, x squared minus 9 equals 0, and then I would just plug in whatever I got for x. So let's start off with the positive 3 first. I'm going to get positive 3 squared minus 9 equals 0. All I'm doing is I'm letting x be positive 3 and just seeing what happens. 3 times 3, that's going to give me 9. So 9 minus 9 equals 0, and then 9 minus 9 is 0. So I get that true statement, 0 equals 0. Okay, so 3 must be a part of the solution set. Let's look at negative 3. What if I plug in negative 3? Does anything change? Not really. So I still have something squared minus 9 equals 0. That negative 3 is going to cause it to become a double negative. So you're actually doing negative 3 times negative 3 right here. That's going to give you a positive 9. So I get 9 minus 9 equals 0, which is 0 equals 0. So negative 3 does belong in the solution set. Why? Because we checked it and we noticed that we got a true statement at the end. So there. Let me get a new layer going. Okay. All right. I'll leave this up there for a few seconds and we'll do number 5. Okay. So 5 is going to be a quadratic formula question. So we need to know the quadratic formula. If I didn't know what it was, I could probably just go back to whatever module it was in on Canvas and find the notes. But I know it by heart. It's carved into my brain, I think. At least at this point. All right. So let me get rid of that. Good. All right, number 5. So number 5 says 6x squared minus 9x plus 1 equals 0. Now, typically what I would try to do is if I have a number out in front that's not a 1, I would start doing rainbow method. So I would probably start doing 6 times 1, which is 6. 6 becomes my rainbow number. So when I draw my MA chart, I'm going to put the 6 under the M. Now, if I was adding, I would have to add up to the middle number right here, this -9. So I start thinking, okay, I got to find 2 numbers that multiply to 6, but at the same time add up to 9. Is that possible? No, it's not. So this is going to be prime. You can't really factor it, so we just call it prime. What I need to do now is, because I'm still expected to find those solutions, is I have to use the quadratic formula. So the first thing I'm going to do is I'm going to write it out. X equals -b plus or minus the square root of b squared minus 4ac, and everything, and I mean everything, is going to be divided by 2a. So what I need to do is I need to figure out what x is. The only way I can figure out what x is by figuring out what a is, and what b is, and what c is. So let's do that first. So a equals, b equals, and c equals. So what is a? A is going to be the first number that you see. This is the quadratic coefficient because it's in front of the x squared. Now, since it's 6, I know that a is going to be 6. The next coefficient that's out in front is going to be out in front of the x. This is going to be a -9. So b is going to be -9. Sometimes we call that the linear coefficient because the x has an exponent of 1. That makes it linear. And then we got this final number over here. That's called the constant. We'll just put it right here for c. So now I know what a, b, and c are, and now I can just plug in. So using the formula, I got x equals -b. That would be a negative, right? A -9. Plus or minus the square root of b squared, which is -9 squared minus 4 times a, which is 6, times c, which is 1. And everything is divided by 2 times a. So really 2 times 6. All right, so I plug all my numbers in, and now I can start simplifying. The negative are going to cancel out, leaving me a +9. Bring down the plus or minus. And over in here inside of the radical, I can simplify this a little bit, right? So I know that -9 times -9 is going to give me 81. And then I'm subtracting something from it, right? I'm subtracting 4 times 6 times 1, which is 24. So 81 minus 24, what's that going to be? That's going to be 57. So under the square root, I'm going to have 57. Pretty hard to take the square root of 57. You'd probably get an irrational number, so I'm not going to try that. I'm just going to leave it the way it is, and then I'm just going to keep on going. Now, what are we dividing everything by right here? We're dividing everything by 2 times 6, which is 12. So here, I've got this big fraction. I've got 9 over 12 plus or minus square root of 57 over 12. And what I can do with that is I can kind of break it up. I can break this up into a plus and a minus. So I'm going to have 9 plus the square root of 57 with everything divided by 12. And I can have the negative, right? Because this is a plus or minus. So I can have 9 minus square root of 57 over 12. So I would put both of these inside my solution set. Now, if you do try and get decimals for these, they're going to be pretty crazy. They don't really have patterns to the decimal points, so just leave it as square root of 57. That makes a whole lot more sense to me. Okay, and to check it, if I wanted to, I could just plug both of these in for x and see what happens. Okay? All right. So those are going to be my two solutions. Remember, when you do the quadratic formula, you have to find both of them. So I'm going to have to use the plus and the minus when I get to my last step. But before that, you're literally just plugging in A, B, and C. That's all you're doing. Okay. Let's do 6 and 7. I can probably do those on the same page. Okay, so let's add another layer to that. All right. Let's see what the pencil looks like. Number 6. Okay, for number 6, I'm given the radical equation square root of 2x minus 3 equals 5. So this is going to be a radical equation. I can pretty much tell that from the radical expression we got over here. This 2x minus 3, it has to come outside of the radical. Now, since it's a square root, I can do the opposite of square root on both sides. I can square both sides. So I'm going to put this side in parentheses, and I'm going to square it. And the 5 over here, I need to put that in parentheses and square it. So what's going to happen is this 2x minus 3 that's on the inside right here, let me do that in red, that's actually going to come out the exact way that you see it. So it's not really going to change at all. It's going to come out as 2x minus 3, and the right side is going to change from 5 squared into 25. Okay, so now I've got 2x minus 3 equals 25. I can get x by itself by adding 3 to both sides. I get 2x equals 28. Then I can divide both sides by 2 and get x equals 14. So that's going to be inside my solution set. And if I wanted to check it, I could just write out my original. And then what I would do is, since I know that x is 14 down here, I could just plug in 14 for x, and it should work. So 2 times 14 minus 3 equals 5. So on the inside of the radical, 2 times 14 is going to give me 28. So I actually have 28 minus 3. That is going to give me 25. Square root of 25 should give me 5. So I get 5 equals 5. Good. That true statement tells me that the answer is working. 14 actually works in that, so that's good. Okay. I have run out of room, so let me get my next layer going. There we go. Okay, 7. So number 7 says the cube root of x minus 2 is equal to 4. So here I actually have a cube root. And what we can do is we can get rid of that cube root by cubing both sides. So that means I'm raising something to the power of 3. So what I'm going to do is I'm going to put everything on the left side inside parentheses. So I got this cube root of x minus 2. I put that inside parentheses, and I cube the outside. Over here, same thing, put everything inside parentheses and then cube it. So now this x minus 2 that's on the inside, it doesn't change at all. It just comes out as x minus 2. Over here on the right side, I've got 4 cubed. That is 4 times 4 times 4. That is 64. Then I've got to get rid of this negative 2. I can do that by adding 2 to both sides. And I get x equals 66. Okay. So that's my answer for that, 66. Let's go ahead and check it. Radical equations are usually pretty easy to check. Okay, so I'm going to let x be 66 and see what happens. I get the cube root of 66 minus 2 equals 4. 66 minus 2 is 64. Should still be equal to 4. And yes, the cube root of 64 is 4. Now, if this was actually a negative 64, which is not, but let's just say it's negative just for the sake of argument, the cube root of a negative number would still be a negative number. So this would actually be a negative 4. That's only if you're taking the cube root of a negative number, which is not true in this case. But it's just good to know. If you try taking the square root of a negative number, that's not going to go well for you. You're going to have to take the negative out as an I first. So your number will not be real. All right, let's look at 8. Okay, so how did I do this? Oh yeah, layers. Good. Okay, number 8. I'm going to change to the ink pen. All right, so number 8 is a rational equation, and I'm given the two fractions 4 over x plus 2 equal to 7 over x minus 5. So these are rational expressions. You can tell because they're both fractions. And what I can do with rational expressions is I can find a lowest common denominator, also known as LCD. Now, do I need to do that for this one? Well, I don't need to do it. I can actually just do cross multiplication. So we're going to cross multiply these. And maybe later, if I have time, I'll show you how to do it by LCD. But the 4 is going to get multiplied by the x minus 5. And I'm going to set that equal to the 7 being multiplied by the x plus 2. So 7 times x plus 2. So now I can just distribute. 4 times everything is going to give me 4x minus 20. Over here, I'm going to get 7x plus 14. And then I just go from there. So I'm going to add 20 to both sides. That'll actually get rid of this negative number. To get rid of this 7x, since the 7 is positive, I'm going to have to subtract it from both sides. So we're doing all this in one step. These 20s are going to cancel. These 7x's are going to cancel. I'm left with 4x minus 7x is negative 3x. And over here, I've got 34. Okay, so I got negative 3 times x. I can divide by negative 3. So then I get x equals a negative fraction, negative 34 over 3. So that's going to be my solution set. Now to check this to make sure that it works, what you could do is you could rewrite the original, just letting x be negative 34 over 3. We could do that and it would work. Usually what I do when I check rational equations is I just make sure I'm not dividing by 0. That's the main thing. That's what I don't want to do. I don't want to divide by 0. So how is this possible? Well, let's say x was negative 2, right? If x was negative 2, then I would have a problem because I would have negative 2 plus 2, which is 0. So I'd be dividing by 0 right here. And if x was 5 over here, that would also give me a problem, right? Because 5 minus 5 would give me 0. I would be dividing this 7 by 0. That wouldn't be good. So x definitely cannot be those two numbers. It can't be 5 and it cannot be negative 2. No way. And if you were to actually graph these two as functions, you would notice that these functions don't even exist at 5 and negative 2. Okay. Let's look at 9 and 10. Let me get a new layer going. There we go. Okay. Probably still in red, but it's fine. Let's do number 9. So 9 says y equals x squared minus 4x plus 12 and y equals 4x minus 4. All right, so if I'm given a system like this, what I want to do is I want to set the quadratic part, which is this top equation. I want to set that equal to the bottom equation, or the linear part. So I'm going to have the x squared term on the left, always. So I'm going to have this equal to 4x minus 4. So now I've got a quadratic equation set up. And I know it's quadratic because the highest exponent is 2. What I can do is I can make the right side equal to 0. That's what I want to do eventually. So that means everything on the right side has to go over here. That has to go, that has to go. So how do I get rid of a negative 4? I would add 4 to both sides. That would neutralize it. And then how would I get rid of 4x? I would have to subtract it from both sides since the 4 is positive. Okay. So now everything on the right side is going to cancel out. I'm left with a 0. And everything is going to show up on the left side. Starting with the x squared, I bring that down. Minus 4 is going to give me minus 8x. And these numbers right here are going to give me 16. Okay, so now I've got something that I can factor. I want to multiply to 16, but add up to negative 8. That can be done using negative 4 and negative 4. So I can actually factor this as x minus 4, x minus 4. So these are
two of the same factors, which means I'm still going to have two answers, but they're going to be the same number. So I get x minus 4 equals 0 from the first factor. And then from the next factor, I also get x minus 4 equals 0. Both of these, I'm going to add 4 to both sides. 0 plus 4 is 4. Same thing on this side. So now I know what my x number is. My x number is going to be 4. So these are the same two numbers, so I really only need to plug back in once. And I'm going to do it in blue. All right. So over here, we're going to plug back in. You can either choose the top equation or the bottom equation. It doesn't really matter. I'm going to use the bottom. So I'm going to use y equals 4x minus 4. I'm going to let x be 4 because that's what I found down here. I get 4 times 4 minus 4. Working that out, I get 16 minus 4, which is 12. So now I can set up an ordered pair. And what I want to do with my ordered pair is I always want to make sure that I put the x coordinate first and the y coordinate second. So I'm going to have x comma y, x is 4, y is 12. That's going to be my solution set. Just 1 point. So if I was to graph these two equations on Desmos, what I would figure out is they only cross once, and that's going to be at the point 4 comma 12. All right. Let's look at the last one. Okay, 10. 10, we've got the same type of question, just different numbers. So I've got y equals x squared plus 5x minus 2, and y equals 3x minus 2. So this is going to be my quadratic part. I'm going to put that on the left side. This is my linear part. I'm going to put that on the right side. So I'm going to get x squared plus 5x minus 2 equals 3x minus 2. Subtract 3x from both sides, add the 2. Subtract the 3x, add the 2. And I get x squared plus 2x equals 0. Now the constants are going to cancel because negative 2 plus 2 is going to give me 0. And I can factor this by GCF because I can't really factor it any other way. What I notice is they have an x in common, so I can actually take that out. Once I take the GCF out, I see what I need to multiply it by to get back to this original right here. So I need another x. And the reason why I need another x is because x times x gives me x squared. And I bring down the plus, and now I only need a 2 because 2 times x will give me 2x. Okay? So now I've got two different equations. I can set this outside x equal to 0, and I can also set the x plus 2 equal to 0. Now this one is already solved for me. I don't really need to do anything to the first one. But this one is going to give me a negative 2. So x is going to be negative 2. All right, so those are my x values. So up here, I'm going to have 0 comma something and negative 2 comma something. The y values are what I need to solve for next. Okay, so I can plug back into whichever equation I want, either the top or the bottom. It doesn't matter. Let's choose the bottom. Y equals 3x minus 2. So my first x coordinate is going to be 0. I get 3 times 0 minus 2, which is 0 minus 2, which is negative 2. So I'm going to put the negative 2 next to 0 inside the ordered pair. The next one is going to be plugging in negative 2. So I'm going to get 3 times negative 2 minus 2. I get negative 6 minus 2, which is negative 8. So both of these are going to be my y coordinates. So put the negative 8 beside the negative 2 inside here. And there you go. Those are going to be your 2 ordered pairs inside your solution set. Okay? Now, if you were to graph both of these on Desmos, you would find out that they cross twice. That's because I get 2 ordered pairs right here. They're going to cross at 0, negative 2, and they're going to cross at negative 2, negative 8. Okay?